Well, hello everyone, and thank you all for joining us for today's webinar. Today we're going to be talking about asset tracking at scale using Bluetooth Low Energy. My name is Michael King, and I'll be your host for the day. Our speaker today is going to be Justin Rigling, co-founder and CTO at Rigado. Justin was a former design engineer at Garmin International before joining Rigado, and he really specializes in low-power wireless systems, design, engineering. He holds an electrical engineering degree from MIT, and he's a member of the Bluetooth SIG group. So we'd like to get started today. Without much further ado, I'm going to hand off to Justin. A couple of notes quickly before I do. If you'd like to ask a question during the presentation, please use the Q&A feature within the WebEx interface to do so. We will accumulate those questions and then answer them at the end. And finally, we will be recording today's presentation. So if you miss parts of it, or if you want to share with a colleague, we will be sending out an email after the event with a link to the recording. All right, here we go. Justin, take it away.
Thanks, Michael. The topics for today's conversation are really to take a look from Rigado's perspective and give you a little bit of idea of what our perspective is on asset tracking, what we've learned about that, with specific look at how BLE has been used with asset tracking. And then we're taking a closer look at some of the different mechanisms that are actually used, the math and the algorithms used to develop asset tracking using Bluetooth Low Energy, and eventually some of the things, the lessons that we've learned doing Bluetooth asset tracking at scale. To give you a little idea about Rigado, we focus on solutions for edge connectivity and computing, so that's gateways and modules for Bluetooth. Our customers are typically large-scale commercial IoT applications. You can think about this as locations that might have carpeted floors, like commercial office buildings. They might also be places like hospitals or warehouses. And our goal really is to reduce the complexity, cost, and risk of delivering these IoT systems. We've been at it for a while. We've been focusing on low-power wireless connectivity since 2010, with a big focus on Bluetooth Low Energy. We've got a lot of devices actually out there in the field between our gateways and our Bluetooth modules, both 5 million connected devices, but also in over 30,000 locations worldwide. And our focus, again, is really taking a look at those things that our customers have to do when developing a Bluetooth application and figure out how to make that easier and how to make sure that the common pitfalls that a lot of developers run into, we can mitigate those risks ahead of time for you. So taking a look at asset tracking in particular, we know asset tracking's been around for a while, and that's because there's a lot of really good long-standing use cases that asset tracking has been used for. Some of them are just locating a thing that you need when you need it, and in healthcare we see this with wheelchairs. You can imagine a situation where the cost of care goes up dramatically when somebody has to go search for a wheelchair and can't find one. Warehouses have the same sort of situation. We're actually seeing this on job sites as well. I heard one example where an extension cord might cost $15 or $20, but if you have to wait a half hour to find it, to power up a tool, and that holds up 2 or 3 workers, that might be hundreds of dollars of lost productivity because you can't find a $20 extension cord. There's also use cases that are pretty common and have been around for a while, looking at, hey, how much of the things that I'm trying to manage in a kind of an inventory sense do I actually have around? Where are they? Are they moving through my logistics chain appropriately? We see that in retail. We see that in manufacturing, looking at the different supplies, different parts needed to actually build something just in time. But these long-standing use cases aren't the only ones that are out there. Today we're seeing some new emerging use cases, exciting ones that if we go back and look at maybe that wheelchair example, understanding the traffic and utilization pattern of something like a wheelchair in a hospital enables the hospital to do something like keep a cache of wheelchairs in the right place at the right times, so that it really reduces the waiting time from looking for that resource. We also see machine learning, looking at things like how many workers may be in a particular part of a building and adjusting HVAC systems to do a more efficient work just based on knowing how many of these resources, in that case humans, are in a place and how to adjust comfort and climate control mechanisms using that information. So a lot of old and several new use cases that we're seeing for asset tracking. And what we find is those things can now be enabled with BLE, and there's a lot of really good reasons for that. So take a look a little bit into the traditional asset tracking approaches. There are really two kinds of tags that are commonly used. One set is the passive RFID tags, where they typically are like stickers, very low cost. They don't have a battery, so they reduce their cost significantly by not having a battery. Their read range, though, because they don't have a battery, they must be excited by a reader system. That reader system is typically a fairly expensive piece of infrastructure and has very limited range. So this is the gates that you normally would see by the entrance to like a retail store, or in warehouses you might see them over top doors or near loading bays, things like that. And those all operate in UHF and with that expensive reader infrastructure. To overcome the limited reading range of those passive RFIDs, we've also got active RFIDs that are out there in the same environments using the same expensive infrastructure, but they actually include a battery and can dramatically improve their read range. But there's still a UHF, usually something in the 900 megahertz band, that is doing that communications. Because the active RFID has a battery and it might have a small microcontroller, more general purpose, you'll start to see some sensors on those devices. But generally we see passive RFIDs have lower read range, lower cost, active RFID, higher cost, but able to be read from a further distance. Now, if we take a look at Bluetooth Low Energy, the Bluetooth SIG has actually been putting a lot of work and intentionally addressing location services as a target market for BLE. And we can see that in the right here, there's kind of four main categories. Points of interest and indoor navigation. Those are the sort of location services where a person walking around with a mobile phone can get more information about the museum piece that they're standing in front of, or in a city center might get some walking tour data, or inside a large building, they might be able to see a little blue dot on their phone represent where they are inside that building and help them navigate inside a structure. Those are interesting, but what we tend to be focused on at Rigado is more of the asset tracking and space utilization items that the Bluetooth SIG is really intentionally building the Bluetooth technology for. If I take a deeper look at where the advantages are for BLE in asset tracking, I mentioned earlier that active RFID can have support for some sensors, but Bluetooth has got a really good set of models and profiles for devices, and it can be fairly extensible. So Bluetooth provides better support for sensors of all different types. If I go back to the wheelchair example, it may be that what you really want to detect is whether the wheelchair is occupied, whether there's weight on the wheels there, and that way you can put that into your machine learning algorithm to say, is this wheelchair being moved around because it has a patient in it, or is it being moved around because it's not where it needs to be and someone has to go move it to a different location? So Bluetooth can provide support for better sensors. Bluetooth has bidirectional communications that are very good. We've been using them between our mobile phones and devices for many years, and using that in asset tracking enables us to do things like configure those sensors that are attached to the asset tags, maybe other parameters like update interval, thresholds for sensors emitting different characteristics, or even do something like update the firmware entirely, so that a sensor that's out there, as you've gotten a lot of data from it. You've learned that you could improve the algorithm, you could improve the battery life, you could do something that makes the product better. Using BLE gives you a path to actually update the firmware on those devices in the field, which is really great. Bluetooth has actually got a good security model, or enables many security models. So if you're talking about patients in healthcare, you're talking about high value assets that you want to make sure that you're the only person or only entity that can track. Bluetooth can be extended to include security for keeping those things anonymized, but also trackable. Bluetooth, since it's in mobile phones, tablets, those devices can actually participate in an asset tracking solution. So that might be the mobile phone is an asset tag that you're tracking as it moves around in a space. That's one way a mobile device could participate. Now you've eliminated the cost of a separate wristband or employee badge or something like that to track a person. Or in the other way, a mobile phone can be used as one of the locators or trackers in this system. We've worked with customers that are monitoring shipments, devices or goods as they're moving throughout a warehouse logistics chain. And inside the warehouse, they use the gateways and Bluetooth to track where that device is or where that shipment is inside the warehouse. But once it goes out to a truck, it then kind of transitions to using the mobile phone that's in a driver's pocket or a tablet that's attached to the truck to be saying, okay, now the device, the asset tag is being tracked inside the truck and now is no longer in the truck, and here's the GPS coordinates from where it was no longer seen. So you can see how mobile can extend an asset tracking network very well, and that's made possible because BLE is natively in all these devices. I think the Bluetooth SIG put out a recent report that said 100% of all the mobile phones, tablets, computers are going to have Bluetooth in it. So every one of those devices can be used as part of the asset tracking network. Compared to the passive tags, BLE certainly has long range. But even to the active tags, you can see some of the improved BLE performance with longer range, which may help with more proximity-based asset tracking. And when you have BLE, which we talked about the UHF readers earlier being kind of an expensive piece of infrastructure, BLE devices are going to be cheaper infrastructure, and because of this longer range, you don't have to install as much of them. You don't have to put one at every door. You don't have to put one at every gate that you want to put packaged goods through. And finally, the UHF 900 megahertz band is fragmented across the world. So in North America, it's 902 to 928. It's 868 in Europe, and I can't remember all the other ones, but in various parts of Asia, it ranges in different bands. That makes it more difficult to have infrastructure and systems that you buy in bulk and then can ship anywhere. In a RFID world, you have to be more tailored to where you're going to actually deploy that equipment. BLE, since it's in a 2.4 gigahertz band, which is a global band, doesn't have that restriction. So it's very nice from that perspective. You can focus on building one set of solutions and deploy that anywhere. So a lot of really good advantages for BLE, but one of the really interesting things that we've noticed in BLE over the last few years is a trend that has been really driven by the consumer markets and the chipset vendors working really hard to support those consumer markets. In just the last few years, I've seen TX power consumption for like a 0 dBm output drop from around 16 milliamps down to 5 milliamps. At the same time, we've seen RX sensitivity improve while the RX current, the power consumption, decrease in similar numbers. What those two things really mean is that Bluetooth chipsets are getting much more power efficient. And if a large portion of the cost of an active RFID solution is the battery that powers them, you can see that Bluetooth is going in a trend that is going to need smaller and smaller batteries to have the same sort of battery life and better performance than it does today. We're seeing more RAM, more flash, more CPU power, which is enabling more sensors down in the asset tags. And then, overall, the cost of these chipsets is going down as we see each one of the vendors that makes chipsets moving to smaller process nodes, which reduces the cost. And all of that, kind of takes Bluetooth as an active asset tag today, similar in price to something like an active RFID solution. We're going to see trends where that cost is driving down closer to what passive RFID is having. I've even seen several companies working on battery-free Bluetooth beacons. So I know of at least 2 that are working on actually getting to the point where they don't need batteries at all. And then RFID, Bluetooth can act almost in the same way as passive RFID, except for it harvests energy from just a 2.4 gigahertz band instead of from a large, expensive 900 megahertz RFID transmitter that is nearby. So, I think it's worth making this a really big point that Bluetooth is headed in a direction where both the infrastructure, the readers, the locators, the gateways are lower cost than RFID, and we're heading in a trend where the actual asset tags are going to be going there as well. So it's a little bit about the advantages of BLE, but let's look at how our customers are actually using BLE to create asset tracking solutions. So first, we'll just take a look at the components of those systems. Over on the left, there are all of the asset tags, and for a lot of our customers, that could be things like wristbands or beacons or sensors, different variations, different types. There's a lot of flexibility with all the different Bluetooth device vendors that are out there. Gateways or locators, the devices that are actually receiving the signals from those asset tags. And then that's typically sent into a location engine, which is computing all the different pieces. And that location engine is worth mentioning in some situations ends up being co-located with the gateways. It might be part of one of the gateways. It might be on premises with whichever warehouse or hospital or commercial office building has this installed, or it might be something that's run in the cloud. And we're seeing both situations with asset tracking with BLE devices. And then finally, that all needs to go somewhere to provide real business value. We see that going into business intelligence systems, which may be doing something like that HVAC system that will adjust based on the number of users that are there. It might go into an intelligent path planning algorithms, but ultimately all these systems need to go into either some visualization or some actual actionable system where it can affect new business. So those are the components. We've got 3 different solutions that we're going to talk about today. The first is fingerprinting. We're seeing our customers use a fingerprinting algorithm, which it's probably one of the more accurate solutions, so I put it up first. And in this solution, you can see there's a large number of Bluetooth receivers, and there's one beacon. Now, when this beacon is sending its signal out, the all the gateways that can hear it are getting a different or a signal strength from the beacon that's being sent. So nearby, you might see something like negative 60 something, further away, negative 90, negative 87, something like that. But every gateway that can read it or can receive it is getting some sort of signal strength. All of those signal strengths are kind of collated together and sent into the location engine. What the location engine is doing in a fingerprinting situation, it's going to compare basically that list of signal strengths versus other lists that it has from a training session. So what does that look like? In this matrix down on the right corner, there are a row of training data, which is the RSSI value that was captured for each reference point, or this RP1, RP2, RP3. Each of those is like a training area where in an offline mode, the system is trained to say, hey, I'm going to put a beacon right here in this reference area, this reference point, this region, and record all of the received signal strengths and average those and then store that somewhere so I can compare against it in the future. And then go repeat that process, that training process, at every one of these regions that you want to be able to get asset tracking information about. So it might be conference rooms that you want to know, is it somebody in this conference room? It might be a patient room where you're saying, is the wheelchair in this particular room? It might be a desk. It might be a table. It might be a service bay in a large repair facility. We've seen job sites where it's, hey, is something in the toolbox or is it in a different region? So in a fingerprinting algorithm, you need to have this training data, which is basically each region you want to look at, and then you need to be able to compare that. The way it's compared is essentially doing a difference of each one of those points, summing all those up, and seeing which one has the least amount of error. So you don't have to have exactly the same RSSI value. You're just looking for which region has the closest RSSI values to the one you're at now. Fingerprinting is a very good mechanism. Some notes about it is that the results from a fingerprinting algorithm typically look like tag number, whatever, is in a particular region. It's not an XY location. It is based on classification of this is where it is. Fingerprinting systems have many receivers. The more receivers that are used in the system, typically the better your accuracy is going to be. One really cool part about fingerprinting is that the gateways or the receivers don't need to be any particular pattern. In fact, you don't need to know before or after you deploy them where they are. Because the system is trained, the gateway can be wherever it was convenient to put it, as long as they're spread out, they're not all on top of each other. But the big drawback, or at least one of the things that must be considered, is that fingerprinting requires a training portion, which every region that you want to get a classification for, you must actually put the device or representative device, a beacon, into that environment and use machine learning to actually train the system, hey, this is location 1, this is location 2, etc. Doing that could imply that it's better to have fewer regions. That helps with the training side of things, but also reduces the amount of computation you have to do, because every time you get a set of beacon data, you're comparing against every region that you have. So that's fingerprinting. The second way we see a lot of our customers building asset tracking using Bluetooth is using a range-based approximation. And so when I say range, I'm saying, okay, the beacon is sent, all the gateways in the vicinity can receive that beacon. Now again, they determine their received signal strength, and they will then use that received signal strength to basically build a range calculation. And this can be complicated. This can require some tuning in the lab to say, I know the signal strength drops off at approximately 6 dB every time I double the distance, but that's a relative measurement. I need an anchor point. I need, what is it at 1 meter? Give me some testing data. So if you have a good calculation, that's why I didn't put one here. I don't have a calculation that works for every situation, but our customers are basically building range calculations based off RSSI data. With that range calculation, you can sort of build these intersecting arcs where each gateway can say, I estimate that the tag is this distance away. You get enough of those, 3 or 4, that the location engine can essentially resolve to an approximate position for the asset tag relative to the XY positions of the gateways or the receivers that are listening. A couple notes about that. Unlike the fingerprinting mechanism, which will directly give you hey, this tag is in this region, the results from something like this is more like hey, here's an XY position that the tag is at. In order to resolve that XY position, it's very important that the gateway locations are actually known. And a lot of times what we see is it requires planning before. So our customers need to look at a floor plan and say, we want to put gateways here, here, and here. and then handing it to a set of installers. If the installer goes on site and can't actually install in those positions, then they'll modify that and send a revised. I actually installed it a couple meters over this way. That's all very important for an algorithm like this because those gateway positions are part of the actual location calculations. One of the things that we've learned from a lot of our experiences with this kind of BLE asset tracking is that the RSSI signals in many environments can be very noisy, and that noise is something that needs to be dealt with either with really good filtering or just knowing that that's going to decrease your accuracy of your location. One of the things that can contribute to RSSI is actually the radiation pattern of both the beacon and the gateway. So if you're basing your range calculation off of RSSI, but the RSSI value is 3 dB different when you're on one side of the gateway versus the other, even if you're at the same distance, that could be a problem or can cause issues with the calculation. Another thing that seems to affect it is if you are going to use multiple vendors for your different beacons, each one of those beacons could have different output power, which again will change the apparent range calculation, and they might have antenna radiation patterns that are not isotropic. So a couple things to watch out for with RSSI-based range-based approximations. And finally, if you do want to get a result which is more like, hey, tell me when the tool is back in the toolbox, you need to use something like a geofence and more software to say this is the area encircled by that basically says when it's here, it's in a certain region. So that's software that's in Location Engine beyond the kind of primitive result of XY position. We've seen most of our customers using a range-based approximation. One of the things that we're looking into now is using angle from the gateway. So actually, the gateways themselves would be detecting every time a beacon is sent out, not just the signal strength, but they would actually focus more on, hey, which direction did that signal come from? And in this diagram here, you can see there's 4 gateways. They each report that information to a location engine and can do a XY position report based on that. We're working, our engineering team is working on angle of arrival. There's a couple different methods that can be used for angle of arrival. One is to have a set of directional antennas pointing out in an array around the gateway, and then using actual RSSI mechanisms to look at the relative RSSI values, music algorithms, and several other algorithmic tricks to say, okay, with high confidence, that's coming from this angle. And then there's also some mechanism using phase and multiple omnidirectional antennas. We're looking into all of those things so that we can provide a angle of arrival solution on our gateways. A couple notes about the angle of arrival solution. Like the range-based one, it resolves to a position typically. Just like the range, you really need to know the gateway locations accurately in order for this to work. For something like those multiple directional antenna angle mechanisms, RSSI being noisy can still add some error. So either look to not use an RSSI mechanism or employ some good filtering. And then similarly, the regions will need to be defined with geofences if that's the way that data is going to be acted upon. So we're seeing a lot of promising things with angle of arrival for doing asset tracking with Bluetooth. And then all of these mechanisms can benefit from edge processing down at the gateways in order to provide better location data. So I kind of grouped them into 3 different types of edge processing that we often see. The first one is When you're in an environment, a commercial office building, for example, there are hundreds or thousands of BLE devices. You may only be interested in tracking a small number of those or a small set, certain type. So a lot of the time, edge processing can be used to filter for certain UUIDs or certain MAC addresses, some way to limit which BLE devices that you're sending the data through the location engines. The location engine has to do a lot of computation. If you could reduce the amount of that at each gateway, that's going to help the system perform better overall. Because RSSI can be so noisy, a lot of the applications that we've seen are employing some sort of low-pass filter or some sort of filtering in the gateway itself before sending data to a location engine, and that helps dramatically. So good edge processing there. Angle calculations can be done actually on the gateways depending on what mechanisms used, and then what's sent to a location engine is not a bunch of raw IQ data or a bunch of raw signals, but instead a much more meaningful, here's an angle and a probability or an accuracy estimation for that angle. All that done at the edge, which improves the actual asset tracking. But we're seeing other classes of edge processing in these same use cases, which are when sensors are combined with the asset tracking solution. So sensor data can be filtered in many of the same ways that RSSI can, so that you have less noise. You can look at the thresholds and say, hey, I care when this temperature is below or above a certain threshold, only send the data when it happens. And really that's partially in service of solving, reducing the amount of data that's actually sent across the network, which is especially important when you have cellularly connected gateways or the system is actually got a backhaul of a cellular connection like we provide on our Cascade series. And then the final way that we see edge processing helping out in these BLE asset tracking solutions is actually helping with the installation process, especially when the gateway needs to be installed somewhere on a map or on a floor plan, or it needs to be oriented in a certain way, connected to a wireless network or get on certain credentials to get on IT networks. A lot of those tools can all be done with edge processing in the gateway itself. So a lot of cases there for BLE asset tracking. So those are the different things that we're seeing in the ways that customers are using our products. But what are the kind of the lessons learned? What can we share that'll help everybody that wants to do asset tracking with BLE? The first few are really installation costs tends to be really important. And so if training is the system is going to take a long time, that's a huge factor. It might still be the best system, but it has to be accounted for when kind of doing the math and the economics for how to deploy these systems. We've seen floor plans. This is a nice looking floor plan that I grabbed and put on the screen here, but we've seen non-existent floor plans. We've seen a lot of trouble in trying to pinpoint those exact locations of gateways so that you can go back and actually have a location engine that has an accurate set of inputs to resolve locations. So good floor plans are hard to find. And then, as some of these location algorithms, whether it's filtering on the gateway, whether it's location engine itself, they need iteration. And so we're seeing a big need for customers to be able to roll out a solution, but be able to actually manage it once it's out there with some new revisions. A couple other ones, and I think I mentioned some of these already. The antenna performance can have a big impact on the accuracy. Isotropic is essentially saying how uniform it is, so how much do we get a consistent signal level no matter which angle from the gateway we're at, if we're at the same distance. And that matters on both the tags and the gateways. So when you're considering your purchases for asset tags, that's something that you might want to take a look into to figure out, hey, does this gateway or asset tag have a good antenna pattern? Because if it doesn't, it could really affect the signal strength numbers and create a lot more noise in the system. Sort of mentioned this already, that distributing the software as you iterate through those better algorithms is important, but what we're finding is customers don't often want to put the newest software at every location, but instead they want to kind of meter it out into smaller groups, maybe a pilot facility. So there needs to be good tools for being able to do that. And we actually solve that problem very well with our EdgeDirect platform. It's one of the areas that we've put a lot of effort. So deploying into a group of gateways is actually pretty easy with our tagging system on EdgeDirect. And then the last one, not too surprising, but IT departments can be very difficult to work with when you're moving into something that's like a big commercial building, a hospital, a warehouse, where they have IT policies. Often it's hard to just plug in a device. They'll want to do a security audit and understand that that device is not going to compromise the network. There needs to be different firewall rules put into place to limit access. And so we've looked at that and we've experienced that with our customers, and we've been building tools to improve the installation process, but also to help with the security story by having secure boot, having encrypted file systems to protect all the assets that are, or the resources that are on the gateway, by providing security patches as kind of part of the Cascade product. So some of the things that our customers are running into when deploying asset tracking at scale, we can certainly help with our EdgeDirect and EdgeConnect and Edge Protect platforms, and there are others like intended performance on the asset tag that you'll have to figure out. The solutions that we have are our Cascade IoT gateways. So in those you may have seen these already, but going into these buildings with all the connectivity you need, Wi-Fi, Ethernet, LTE, or power over Ethernet for powering, those sort of things. But also the modules. So if there's a sensor that doesn't exist out there, there's not an off-the-shelf way to detect weight on wheels in a wheelchair, and you want to create that, you can use our Bluetooth 5 modules with microcontrollers inside to actually do all of that work and participate in the asset tracking. And then, one of the last things that I'll say here is, if I take a look, our Cascade solutions are not just for asset tracking. We see a lot of really great use cases there, and great customers working on that. But we also see control and automation, different use cases with HVAC, like I mentioned earlier, or just sensing and monitoring. So maybe it's not looking at the actual location of something, but hey, keeping track of, is it in the right temperature range, or is it occupied, or things like that. So a lot of great uses for Cascade there. But certainly we're seeing a lot of activity around BLE asset tracking, and we wanted to share with you today the kind of lessons learned and some of the different ways that we've seen our customers do that. So I'll turn that back to Mike, and we'll see if we have some questions that we can help answer for the group.
Fantastic. Justin, thank you so much. It was a great presentation. Hey, we do have some good questions here, so let me roll through them quickly. So the first one here is, what kind of accuracy are we talking about in terms of the different asset tracking solutions? And I know you mentioned 3 different ones, so I'm not sure about how you can answer that, but accuracy in terms of an actual number of feet or meters in range.
Yeah, that's a good point. Probably something I should have added in. Typically, for something like a fingerprinting system, we're seeing something in the 1 meter accuracy. The range-based solutions are closer to 2 meters, so not quite as good. And then the angle is that there's still that's still a newer solution, and so I've seen some preliminary numbers that are less than 1 meter. But I'm gonna say stay tuned on that one, because we still have a lot to learn in larger scale deployments.
Fantastic. Okay. The second question is, to identify a device, one way it seems like you could pair with it is, are there other ways to identify a device with a name or something like that?
Yeah. So there are and I think the question might be saying, hey, I've got a bunch of assets that I want to track. How do I know which asset is actually wheelchair number 1, 2, 3, 4, 5, or something like that?
Right.
Typically, what we're seeing our customers do is they're using the MAC address of the beacon as kind of the unique identifier for that device. or using something in the advertising data. Maybe it's a UUID, especially if you want to add security and you want to have like a rolling identifier. They know that before they actually deploy these devices, either because they've used the mobile phone app to very accurately say this device is, MAC address, whatever, is now being linked in my database to be wheelchair 12345. That's typically what we're seeing. There might be other methods out there, but that's usually what's happening.
Fantastic. Okay. The next one is, could you please let us know if there's something happening in BLE beaconing using some form of mesh?
There are certainly, if you take thinking about the range-based application of doing asset tracking, or essentially you have a network of receivers that are listening for beacons and then sending that data through a network to a location engine. That's a way that could be implemented is by using a mesh, a BLE mesh, where the BLE mesh devices are both sending data to each other and through a network of mesh devices, but also listening for other asset tags and typical beacons that are out there. That's a way that could be implemented. I'm not sure if that answers the question. Hopefully it does.
Sure. Yeah, then there's a related question here about can you use the gateways as repeaters as a way to gain distance possibly there as well?
Yeah, certainly. I mean, the benefit of the Cascade 500 is there is essentially a Linux operating system there that runs containers. If one of our customers wants to build a repeater system in software that runs on the gateways, there's a lot of opportunity to do something like that, and that takes advantage of really the flexibility of our edge processing, this edge gateway. So that's certainly very possible. It's not something that we have a solution for out of the box today.
Fantastic. The next one is, you mentioned that some of your devices function as edge gateway processing devices. What amount of edge computing and processing capability is inherent within your devices?
Yeah, so I think the question is, like, when I say it's an edge processing device, what does that really mean? What that means is the gateway is running a Ubuntu Core Linux. Ubuntu Core Linux has a set of containers that you can deploy called snaps. A snap is essentially a wrapper around a typical Linux utility. So if you have a Python script that you've built on your laptop and you've used that to filter down data, or a Node.js or a C or Go or Java, any of those languages, if you've built an application that runs on Linux, it's not too difficult to turn that into a snap. And then using our Edge Direct platform, you can actually use that as an orchestration tool to deploy that snap out into all of the gateways that you want to have running that software. And then once it's deployed, you can see kind of a live view of things like CPU, RAM, disk usage on all of those gateways where it's deployed, so you can kind of get a sense of health. You can retrieve logs through the Edge Direct platform, things like that. That's what edge processing and edge compute means on our Cascade system.
Fantastic. Next one here, BLE5-based beacons are yet to make a big appearance. How do you see its future in this regard?
Well, I think BLE5 added three main things. It added longer range, it added higher speed PHY, and then it added advertising extensions. And I think it's probably nice to have backwards compatibility with other beacons. I mean, Bluetooth 4.2 has been certainly very sufficient for being able to have a lot of beacons out there in the market. So I doubt that we're going to see 2 megahertz or 2 megabit mode really playing too much of a role in the near term. And then the longer range PHY, fortunately, can actually be run at the same time as the 1 megabit mode. So you could see those coexisting. And that would be valuable if you wanted to do more of a proximity-based asset tracking, saying, hey, this tag is on maybe it's a farm, and you want to know when is it near the barn or the feedlot or something like that. So I could see long range being used in that way. And then finally, advertising extensions. Advertising extensions enable maybe richer set of sensor data to be sent from a beacon to an asset tracking system. So this is one where there's obviously some hoops to jump through because the receiver is going to have to follow that advertising as it's jumping to different channels. But if the purpose of the asset that you're tracking is to actually also convey sensor data, and that sensor data might be more than just a couple bytes, extended advertising provided by Bluetooth 5 actually builds a better mechanism for doing that. So those three features, that's how I see them being used in asset tracking with BLE.
Fantastic. Great answer. Thank you. What about the Z-axis? It seems all the tests have been done with XY only.
Yeah, it's a great question and something I left out. And it's actually, there's some caveats to say when you're looking at some of these range calculations, there are 3 dimensions in use. Often the gateways are on the ceiling, and the devices being tracked are they're not on the ceiling typically. They're on pallets, so they might be really close to the floor. They're on desks. They're in different places. So there are some considerations when doing the algorithms for asset tracking that you need to have accounted for what is the height difference between the assets being tracked and the locators. But typically what we're seeing is doing that math is kind of like saying, okay, we don't really care about the Z-axis for the asset tags. In some situations, that's not acceptable. For example, if you're looking at which shelf an item is placed on, you want to know fairly well what XY position it's at, but also what height above the floor it's at. And in those situations, we've seen a couple novel approaches where the asset themselves, the asset tags themselves, have an additional sensor. They have a barometric pressure sensor, and they will, in addition to their beacon data, will include that pressure reading, and then there'll be other barometric pressure sensors that are fixed to known heights, and you can compare between the known height pressure reading and the one from a beacon to find a better Z-axis value. But typically, that's more appropriate, like I said, for which shelf is it on, and a lot of the applications care more about which room is it in.
Fantastic. Thanks so much. Hey, next question here. Can you integrate several or all of these methods together to improve accuracy?
Yeah, I mean, absolutely. The range and the angle together can be combined. It's more math, but you do start to see some of the benefits of reducing the errors. Now, fingerprinting could, certainly we've looked at how can we use angle as part of the fingerprinting algorithm, because realistically, what you're doing is you're just comparing a set of data that was true during the training to a set of data that you have now when the system is online. So perhaps instead of having 25 or 16 in the picture I had, gateways spread out, you have a smaller number of gateways, but you add angle information into that fingerprinting algorithm. So you're still doing training, you're still looking at when is the asset in a particular region, but some of the data you're feeding into the algorithm is angle instead of range, or angle instead of signal strength. So absolutely, you can mix them all together.
All right, great. Next question here. Has there been any consideration of gateways with dipole antenna using Doppler to get accurate angles for information?
Yeah, so there are some considerations. Dipole is a fairly omnidirectional in one plane. There are other types of antennas that have similar omnidirectional in one plane that we're looking into. And, I can't go into a whole lot of the details, but essentially looking at the received signal at 2 different antennas, if you can compare the phase of the signals of each one of those antennas, there's there's an ability to sort of discern which angle is that signal coming from. So we're taking a hard look at solutions. We're working with some partners to bring that to one of Rigado's future gateways.
Fantastic. Okay, next question. I'm working with tags that transmit sparsely, about every 5 to 10 seconds. Are the BLE receivers on the gateways likely to be adversely affected because of this?
No, I think one thing that's worth pointing out, the receiver that's in something like a mobile phone is really competing in many ways with other radios and with battery life. So on your iPhone or your Android phone, the Bluetooth receiver is not on all the time. It's actually asleep more than it's on. But on the gateways, these devices are very purpose-built to do Bluetooth, and that's really their purpose is to receive Bluetooth signals. So their receivers will be on 100% of the time, except for if it needs to transmit. And that comes down to good, intelligent software design, is saying, hey, I'm not going to transmit all the time because I want to be receiving all the time. So having it transmit every 5 or 10 seconds isn't a problem. The gateway should receive those. The other thing I'll mention, though, is if that device is moving around a lot, you might want to consider the trade-offs of getting intermittent signal readings as it moves versus maybe it's worth it to turn the advertising rate up, and that way you get more messages and get more filtering, smoothing of the RSSI values as they come in. And I guess the last thing I'll say about having the receivers on all the time, we do have Wi-Fi in our gateway. The Wi-Fi radio supports both 2.4 gigahertz and 5.8 gigahertz. We recommend that for an application like asset tracking, that that if Wi-Fi is used, that only the 5.8 gigahertz is used, and that way there's no Wi-Fi traffic in the 2.4 gigahertz band right at the gateway that can affect the receiver. So there are certainly things to be considered when you're have more sparsely transmitting beacons, but the system should work.
Fantastic. Okay. You mentioned extending range with mobile phones. Does this require permissions of the user?
Oh, certainly. Yeah, this would require that there needs to be an app installed on that phone that it essentially extends the I would say use case in a way that the driver or user or operator would be aware of and have to consent to. I think that's required.
Great. Next question. I wanted to avoid having to pair to simplify the user experience. Is UUID/MAC address available for devices that are not discoverable?
Yes. In the advertising PDU, packet data unit, there is a MAC address, and then there are like 31 more bytes that can be populated with a variety of different things. So the MAC address is always there, but the UUID depends on what the beacon vendor has basically programmed it to do. So in the case of an iBeacon, there is a UUID there, and then there's a couple other things like a major and minor number, and I think there's a service UUID or a manufacturer's ID, a service, and then the UUID that's kind of part of the iBeacon system. So if you want to filter on that, then it really depends on what beacons you're using. One of the notes that I'll say that's different between something like an iPhone. iPhone obfuscates that MAC address, so you can't actually see what that MAC address is. On our gateways, we give you access to what that MAC address actually is coming from the device. So if you want to filter based on MAC, or if you want to use that MAC address as the identity of the tag you're tracking, you have the ability to do so.
Super. Okay. Next one here, and we're getting close to the end. I apologize. We're kind of running into the end of time, but we'll get to as many of these if we can. So the next one, how long do you expect the battery life for one of these BLE asset tracking tags to generally last?
Yeah, I mean, it's a question that doesn't have a single answer, and I'd have to pull out a battery life calculator, which is going to take factors like, am I reading a sensor? Am I doing any computation on the sensor, which requires processor? And what is my advertising interval? That all said, I've seen some asset tags with batteries that last 6 months, and I've seen some that last 6 years. So it's very dependent on what the software on the beacon is doing.
Great. Okay. When designing around these different BLE asset tracking options, what are the most important things to test early on?
Yeah, I'd say that one of the things that we've learned with RSSI is it's not as stable as a lot of people expect it to be. Meaning, get your beacons that you want to use, get the gateway, set up a test where you actually just take a fixed distance and see what range of RSSI values you get. There's going to be some noise there. Do some algorithms to filter that, and then do other tests to see if that is going to be stable enough for the algorithms that you're using. Now we have customers that have been successful with it, so I'm sure it can be done. But as you're trying to figure out if the system's going to meet your needs, that'd be one of the first things that I would do.
Okay, well, thank you all again for your participation today. I really appreciate everybody hanging on here with us almost all the way to the end. That's fantastic. Great questions, Justin, great answers, great presentation. Thank you for your time today. As a reminder to everybody, the presentation is being recorded, and we will send out a link to everyone that attended and those who registered with a link so that they can watch in an on-demand version later. So again, thank you all, and we look forward to bringing you another fantastic webinar next month. Look for it in your inbox. Thanks so much. Bye-bye.